All right, so I had to leave school finished, so I'm at home. Carrying on this question about this tennis ball. So this is question E. Calculate the total time that the tennis ball spends in the air. Now, we have already calculated stuff about this tennis ball. We found out in a previous question the maximum height vertically from the ground that this tennis ball travels, okay? So that's information we can use now, because if the total time that tennis ball is spent up and down, we need to consider, well, how long has it taken to get from its original launch position, which was already 3 meters off the ground, how long did that take to get up? We calculate that in a previous question as well. And then, well, how long does it take from here all the way down to the ground, because that's actually going to have a larger distance to travel vertically. So we do have to think vertically for this question. So we'll just pop that there. It can be really hard to know if you have to think vertically or horizontally, so it just takes a bit of practice. But the time it took to get from its original position to its maximum height, I believe, was 0.44 seconds. We calculated that in a previous question. So to get from here to here, 0.44 seconds. But how long does it take to get from there down? Time is, we don't know. But we know a lot about the ball when it's at that position, at its highest vertical point. We know that it's to go from there down, if that was its starting place, its initial velocity there would be 0 vertically, because that's when it's just hovering in the air for a split second. So the initial velocity of that tennis ball is 0 vertically. We know that it's falling, and the only force that's making it do that is gravity. So if the ball is going down, the acceleration is going down, you could have the velocity and the acceleration with the same sign, so either both positive or both negative. If you want to keep your frame of reference, if they're both moving down, you may say that that's the positive direction. So we can keep that. Doesn't matter, because we're trying to figure out time, and time is not a vector. So you're not going to get a positive or negative time, it's just going to be an amount of time. And we also know this vertical distance. Now, I did say before that you can't really, I don't like to use information I've previously calculated in case there's a flow-on error. But in this case, you're going to need to know, well, how far is it going to fall before it hits the ground. So distance, don't use your rounded figure. So if it is stored in your calculator, use that. I'm just going to round that to 3.96. And what we're trying to find now is the time. So we need to find a kinematic equation that does not have VF in it, which I believe is this one here. So again, we just have to substitute our numbers in and solve for t. This here is going to have t squared, right? So we're going to need to do a square root somewhere along the way. So let's have a look. I'll just move this out of the way. D equals VIT, again VI is 0, so that cancels that whole part out, so it just leaves us with positive half AT squared. So half of A, again you could use the negative or not, because it actually doesn't matter for this question, and then T squared. So you could take this over here and divide it. So we can go 3.96 divided by whatever that is, half of 9.8, which would be 4.7. Just double check, it's a bit late for me to... No, 4.9, yes, that's why I double checked. Equals t squared. 3.96 over 4.9 is 8.08. Oh, 0.808, sorry. equals t squared. So square rooting that leaves us with 0.89897. Oh, okay, so what's it going to be? 0.899. So that is how long it took to go from the top down. All right, so the actual question wants to know the total amount of time spent in the year. Oh, total T, oh my goodness, I'm such a klutz today. It's going to be this figure we calculated earlier plus our 0.899. Which gives us a total time of 1.34 seconds. So rounding that to 2 sig figs would just be 1.3. So that's how we calculate the total time. I hope that helps, because this is often a question that can be a bit confusing, because you've got to consider half the journey going up and then calculate the other half of the journey going down, because in this question they are different because we started at that 3 metre height.